Hello, Professor. This is homework number 3. I'm going to switch over to just the homework screen and the code so we can go through this simpler. I've been going through the homework nonstop the past week, so I've already completed homeworks 3, 4, and 5. Also got my AWS instance running, so I'm going to try to knock all these videos out by tomorrow for the class. Alright, I'm going to switch over to code and hopefully we can get through all this pretty quick. There we go. Awesome. Alright, so here's the code I have for question 716. We created our styles in CSS. So we're creating a table with values using a for loop in JavaScript to display a multiplication of a value times 10, a value times 100, and a value times 1,000, and it will be written into the table as it goes, and it's only going to run until our value reaches 6. So for the code, it outputs to 1 to 6, the value times 10 for n, the value times 100 for n, and the value times 1,000. Alright, moving on to 720. Okay, for section 720, we're having the user check for a palindrome. So we're going to have the user enter a set of numbers, and we're using an if statement checking to see if those sets of numbers that the user inputted is going to either be a palindrome or not a palindrome. If it is a palindrome, the if statement will alert us, letting us know that it is, else it will display it's not a palindrome. And if the user enters an invalid set of numbers, we have a check for that, and we have a button to check for the palindrome in the body. So we're going to test that out. Alright, and if it's not, it's not. And if it's invalid. Alright, for 722, we're creating a function for encrypting information. So we're going to have the user use a button. We're going to have him input a 4-digit set of numbers. If the numbers do not equal 4 digits, the user will be prompted to input a valid 4-digit set. The user's numbers will be checked, and then the user will input the set of numbers, and then we will run a for loop to encrypt those numbers, and the output will be printed onto the screen. So let's try that out. 1, 2, 3, 4, and we have an encryption of 0189 from how we did our for loop. For 723, we are going to do the opposite of this. We're going to decrypt a set of numbers. We're going to have the user input a encrypted set of numbers from the previous problem. We could use the same ones that we had before. We had 0189 as our encrypted numbers, and we're going to use an if statement to check to see if the user inputs 4 numbers. We're going to have these numbers inputted in. We're going to have the user input these numbers. We're going to run a for loop to decrypt these numbers, and then we're going to print out our value for the decryption for the numbers. This function would run the formula to decrypt the same way that we encrypted in the previous problem. Alright, and it comes back 1, 2, 3, 4. 0189, 1, 2, 3, 4. Moving on to section 8.9, we're creating stars using loops. So we're writing a for loop where the user is going to input a number between 1 and 30 5 times, and then that the nested for loop is going to write out the stars of how many will print out for each of those. So I'm going to do an example of 8, 9, 10, 11. 12. All right, and we have the stars outputting for the amount that we entered. All right, for 8.11, we are creating a table. We are creating a retail value calculator where we're going to have products as if this is something of a register. These products will be used in a while loop. The while loop will have the user input these numbers because there can be as many amounts of each product as the user wants. If the product, we're going to check the product ID. The product ID is going to be between 1 and 5 for what's being sold, and then we're going to have the user enter in how much quantity they're having of these products. So we're going to use a switch case statement to add the products that the user has, and then we're going to have that quantity of how many products multiplied by the price of the product. So for product 1, say if it was one product, would record at $2.98. If product 2 was one product, it would record at $4.50, and then so on and so forth. For however many that the user enters, we will have a total amount, and we'll have it all printed out onto a table. So we're going to enter a product number between 1 and 5. I'll say product 1, and then we'll say we sold 5 for product 1. Product 2, we sold 6. Product 3, we sold 2. Product 4, we sold 12. And product 5, we sold 4. We'll press 0 now to have our table print out. We could continue to go on with this, but we're just going to press 0 to stop. See how our table comes out. And our total sales for each product that was sold. So product 1 would be $14.90, product 2 would be $27, product 3 would be $19.96, product 4 would be $53.88, and product 5 would be $27.48. We're multiplying by each of the prices that we set in the switch case. All right, moving on to 9.19. We are creating a problem that will give us prime numbers. So we're going to use a for loop to check to see if each of these numbers is prime. We could set the minimum and maximum amount of prime numbers we want here and here, and we're going to use our array to check. We'll use our array to check the prime numbers, and then we'll use a for loop to get a array of the maximum amount up to the maximum amount of prime numbers that we have. We'll also use a for loop to check the length of the prime numbers and make sure that each of these numbers is prime. We'll use a for loop to check the array, see if it's true, and then we'll use another for loop to print the prime numbers out onto the line. Then we will write out the prime numbers onto the page. So this is what we got as our result. All right, moving on to 9.22. Moving on to 9.22, we're doing multiplication problems. So we're going to we'll create a style for this. Then we're going to create a body for the problem that we're going to present. And we're going to have two functions to make the equation for our problems. We're going to use a function to generate each question. Each of these questions is going to be a randomized multiplication table, and then we're going to have it print out as we continue answering by clicking the button. So our second function is going to check for correctness and then give feedback to each of these questions. So our feedback will be very good or no, please try again if the user gets the question correct or incorrect. So let's try it out. 3 times 3. Very good. 1 times 7, 7. 9 times 7. Let's go for something that's wrong. Let's go 3. No, please try again. Alright, moving on to 923, we're creating math problems with various responses. So we're going to use the same as in 922 with generating the questions. We're going to have the same check answer, and then we're going to have another function for feedback. This function for the feedback will be randomized for 5 switch cases, where we're going to have very good, excellent, nice work, and keep up the good work. And then we're going to have another function for displaying incorrect feedback. So it's going to be no, please try again, wrong, don't give up, or no, keep trying. And then these questions will continue to generate until the user decides to stop. So we're going to try it out. 2 times 5, 5, don't give up. 2 times 5, 10. Excellent. 5 times 7, 3 or 4. Don't give up. 5 times 7, 35. 7 times 6, 2. 7 times 6, 42. Nice. So it will be randomized on whatever responses are given. This is similar to a former question that we've done in JavaScript, where we created a similar kind of test. Moving on to 924, we are creating a multiplication table with correct or incorrect answers being recorded. So we're going to have a total amount of questions of 10. From this, we're going to use what we did in 922 and 923 to add on to additional functions to check for a correct or incorrect count as we're going along this. So we're going to generate these questions. We're going to have a function to check answers. So if the answers are true, it'll count how many is true. If it's false, it'll count how many is incorrect, and then it'll update as a total. Question count is equal to 10, it'll evaluate performance, else it'll generate questions. So it'll go all the way up to 10. If the question count reaches 10, it'll evaluate the performance, and then it'll generate a description showing how many is correct and how many is incorrect as a percentage. We're going to continue with the random feedback. We're going to use if-else to check if it is correct or incorrect. It will describe this as randomized in this array. So we're going to have another function for random feedback. Let's check if it's correct or incorrect. If it is correct, we're going to use an array to give a randomized response for these messages. If it is correct, we're going to use an array to give a random choice for if it is correct for the message. And if it isn't, we're going to use a separate array to check to see if it isn't correct. It'll give a response, no, please try again, wrong, try once more. And then we're going to use random index to randomize what messages are displayed. We're going to use random index to display what messages are displayed for the user. We're going to have another function to check to see how much the user gets correct. So we're going to use an if statement to check how much percentage the user has correct. If it's below 75, feedback will print out, please ask your instructor for extra help. If it is above 75, a message will print out saying, congratulations, you got so-and-so percentage correct. Then we'll have the correct count, the incorrect count, and the question count updated into the statistic. After all these functions are complete, it will generate a new set for the questions. So let's try that out. 3 times 2, 6. 4 times 9, 27. Wrong. 2 times 4, 8. Excellent. 5 times 1, 5. 4 times 2, 8. 1 times 2, 2. 3 times 2, let's put 1. 4 times 8, 1. 7 times 7, 7. 3 times 6, 4. Please ask your instructor for extra help. So let's keep going. All wrong. Please ask your instructor for more help. Alright, so we got our correct and incorrect displayed. Alright, moving on to 927, we're creating a math quiz. We're going to use the same materials that we've used in 922, 923, and 924 to create this. We're just adding on to it further. So we're going to first start off with buttons. So we're going to have 2 buttons that we're going to make. We're going to make one to choose what grade level, how many digits we want. So grade 1 would be single digit, grade 2 would be 2-digit numbers, and grade 3 would be 3-digit numbers for each of the problems. And then we're going to have another button for what types of problems. We could have addition, we could have subtraction, we could have multiplication, we could have division, or we could have a random mix of all the numbers. So let's actually start off with that. We're going to select grade level 1. You'll see 2 sets of single digit numbers, 2 sets of double digit numbers, or grade 3, 2 sets of 3-digit numbers. For we're going to have addition, subtraction, multiplication, or division. Let's try 1, addition, 2, subtraction, 3, multiplication, 4, division, and 5, something random. Alright, let's go over the code. So for the code, we're going to have a function to generate each of the questions. So if it's a single digit number, we're going to have case for single digit numbers. If it's double digit numbers, we're going to have a case for double digit numbers. And then if it's triple digit numbers, we're going to have a case for triple digit numbers. Else it's going to default to single digit numbers. All right. Also, we're going to have a switch case for what type of problem it is. So if it's an addition problem, we're going to have a case for an addition. We're going to have it structured so the user has an addition problem. Case 2, we're going to have it structured for subtraction, so we're going to have it structured if the user is using a subtraction problem. If the user is receiving a subtraction from. We're going to have a case for multiplication, so if the user is having a multiplication problem, we'll use this code for. If the user is having a multiplication problem, we'll have this case for multiplication. We'll have a case for division. So if the user is having a division problem, we're going to use this case for division. This will give the user a division problem. And we'll have a case for something random within this. So it will randomize its choices from cases 1 to 4. Otherwise, it is a default multiplication. We're going to have a function to check the answers. We're going to have a function for checking answers for correctness. So we're going to use an if-else to check for answers that are correct and incorrect. And then we're going to have an if-else to get the final grade and generate the total amount. We'll have a function to update the grade to show what is correct and incorrect as the user answers his questions. If it is correct, the user will have a feedback response that will be very good, excellent, nice work, or keep up the good work. And if it is incorrect, the user will have a response back for no, please try again, wrong, try once more, don't give up, no, keep trying. The feedback response will depend on if the user gets the answer correct or incorrect, and the feedback will print out as the user answers it. We'll also have a function for final grade, which the user will receive a final grade percentage based on what answers they had correct, incorrect, and how many questions that they answered as a percentage. Once the user fully completes all the questions, the results will print out. We'll have a function for choosing the grade level, so we will get a pop-up via the prompt, and the user will choose which grade level they want, grade level 1, 2, or 3, to choose their single digit, double digits, or triple digit for each problem. And then we'll have another function for choosing what type of problem that they will receive for addition, subtraction, multiplication, division, or a random mix of all of them. As these functions run, once the user completes a test, it'll generate a new test afterwards. So if we test this out, let's just keep going. We won't go for correctness, we'll just go for getting a result. So total score will print out of 0%, and the user will be prompted to refresh to restart the quiz. Can choose it like that. Each of The user can choose what level they want, and the user can choose what type of prompts that they would like to receive. Moving on to 1014. All right, for section 1014, we're going to be creating a table for rolling 2 dice 36,000 times. We're going to use a function to check the frequency of each possible side for the sum of all the dice. So since we're going to be rolling 2 dice, we're going to have a range from 2 to 12. So we're going to create an array for that range. We're going to roll the dice 36,000 times. We're going to have the results of each of the dice be recorded for total, and then we're going to increment it from there to get a different amount each time when we run our when we launch our page. So none of these are ever going to be the same. So we created a function and it's going to print the results. We created a function for rolling the dice. We're going to use math_for, math_random to check to see a range in between numbers 1 to 6 for each die, and then we're going to use those in the roll die. And then we're going to create a function for our results, which will create our table, clear up any unnecessary information left in our table. We'll use a for loop to get our range from 2 to 12, which will print out for our results. And each of these is just creating each part of the table. So the sum of each section from 1 to 36,000 will print out per each roll. And these will be our results. Alright, moving on to 1017, we're going to create a tortoise and a hare race. This is similar to what we've done in C# when we created our games at the end of the semester. We're going to initialize each part of this. So we're going to have the position of the tortoise and the hare start at the same point. We're going to have the finish line end at 70. We're creating a length for how long it is. We'll have a function for the tortoise and for the moves that the tortoise has. So what was given in the description in the textbook is the tortoise can do a move that will add 3, cost a move that will subtract 6, or do another move that will add 1, depending on what move it's doing. We'll use an if statement for the position of the tortoise, and then we're going to do the same thing for the hare. The hare has a different set of numbers that were presented in the textbook, and then if the position moves, the position will move for the hare. We'll use a function to generate what move that the tortoise and the hare will both use on each other for this race. So as the hare moves, as the tortoise moves, we'll have a different set each time using the random class, and the results will vary each time for who will win. So it's similar to what we did for the the guessing game. We'll have a function to print the positions for the tortoise and the hare. We'll use a for loop for the positions. So as the tortoise and the hare move, we'll have an output for ouch, an output for the tortoise, and an output for the hare, and an output else if the tortoise and the hare aren't moving or there was an event that happened between the two. We're creating lines in our boundary. The output will cause it to move, and the output will display onto the screen. We'll have lines printed out for bang and they're off to start off this tortoise and the hare race. We'll have lines printed out for the tortoise and hare to start off this race, bang and they're off. And as the race continues on, we'll use an if statement for each of the positions of the tortoise and positions of the hare. We'll have a function to set intervals for the tortoise and the hare to print out the positions. If the position of the tortoise and the hare change as it's going, we'll be able to see each of the changes as the program runs. We'll set it at 1,000, so as we see this play out, we're going to see the tortoise moving and hare moving at 1 second each, so every second, and the output will change each and every second that the race goes on for until it reaches the end. Then the final output display will either display yay, the tortoise wins, depending if the tortoise won, or the hare wins, yuck. I'm going to skip ahead to show the results all the way at the end, just because this may take a little bit of time. And we've gotten our results. The hare wins, yuck. And that's homework 3.